And I would like to begin with Mr. Kadam. It's like, what are the tangible benefits of energy efficiency, in reducing waste, costs, and emissions across different parts of India's power sector? And how can these advantages be maximized?
And it's about efficiency in everything and anything we do. Because energy and resource is one aspect, but there's efficiency improvement in the operations also what we should not lose sight of. Let's come to resources part. You have generation, transmission, distribution. Then you have the retail. In our country, distribution and retail is one business entity. It's a distribution licensing concept. Now, for every 1 unit you lose at the distribution end, there's probably 4 units of primary energy lost in the generation side, right? So, energy efficiency is the lowest hanging megawatt concept, which can bring more gains. When I say energy efficiency, it is demand side management for the entire power sector, right? So you save 1 unit, you save 4 units of the price. That's one part. Now, how do you bring energy efficiency? You need to measure something what you want to optimize, right? So unless you measure it, you probably will not do it. So you may have basic systems of metering to bill consumers, but do we have incentivization or mechanisms to make people energy efficient passively? That means, are there incentives for them to use less energy? Are there incentives for them to participate in demand response? Are there regulatory frameworks helping our commercial, industrial and residential stakeholders, so-called facility managers or the house owners, to be energy efficient? You have some states like Karnataka who are declaring free electricity energy. Those are all political propaganda. Those are all political things. But we are missing incentivization for energy efficiency on the demand side. The only incentive is you generate less bill. There could be many more initiatives or many more incentives which can be brought in for energy efficiency. Okay. Of course, there are perform achieve trade schemes at the industry side, but we may have to do more to get the 25 crore metered connections in the country approximately, which is serving our population of 1.4 billion. So that's where you get the bulk of energy. Now let's come to the distribution company itself. In the distribution company, as Mr. Dr. Bhaskar said, you have so much of data which is getting generated. Of course, through first of the project, ESL project. What are they doing with the data? It's just meter to cash. Do I get the data? Did I generate a bill? And that's it. It's a gold mine of data. Probably you can do much more using that. A simple example is a cluster of low voltage, commercial industrial residential, low voltage network and a medium voltage network in the distribution parameter. I could do modeling using the smart meter data, which is just lying dormant there, to see what is the dynamic topology of my network. Plus, I can do an energy balancing study. Many a times the unbalance creates a lot of losses, right? I don't know whether I have proper, topology which can give me the most efficient network per se, right? I don't know how much of reactive power my network is dealing. I don't know what's the overall power factor or branch power factor. So there's so much what we can do with that data. So we need to see, one is buying systems, generating data, another is using it. So the institutions or the technology users should graduate to the level of making the most out of the investment. It should just not stay there. Okay? Then comes the medium voltage network, right? They have evolved over a period of time. We don't know the topology, whether the nearest source and the load is connected or whether the load is connected from a farthest source, we don't know. There are technologies which has been bought by the utilities today, but not used, unfortunately. It's pity. We only use the SCADA functionality. There are functionalities like distribution management system, which can do feeder reconfiguration for loss minimization, which can do feeder reconfiguration for balancing. I don't see utilities using it in the country. It's a competency issue. right? So while the specification or technical systems do have it, it's underutilized. Okay. Then comes to the transmission. In transmission, we are operating energy management systems, the transmission EMS from a long time. I should say they are the most efficient in the entire value chain, right? Then get to the generation side. The generation side, there are various angles of energy efficiency per se, the mechanical side of it, the balance of plant, the grid connectivity side of it, right? So as a whole, in the technology user space, in the electricity using consumer space, there has to be policies which promote energy efficiency. Unless and until it is not. Let me give an example. The regulatory framework for our distribution companies today, the framework itself is not energy efficient promoter. You know, unlike the other countries, there is a lot of incentivization for the distribution company to invest, to get the return on investment, which helps them to think of energy efficient investments in the regulatory regime. In India, it is not like that. So probably fundamentally there is a policy-driven initiative which needs to be worked on. So I stay here.
Moving forward, Mr. Parekh, how do you analyze the benefits of these advancements in the power?
So Sohail, the first and foremost thing as a user, the biggest benefit that's going to come is one, availability of power, and second, availability of good quality power. When I say good quality power, we are talking of, let's say, power with without any major disruptions, available without any outages. The second important aspect is these reforms are aimed at ensuring that we are reducing our carbon footprint. We are reducing our dependence on fossil fuels, and we are trying to reduce also our dependence on the hazardous gas. While we talk of the reduction of the fossil fuels, one major element which I talked about was the energy storage. And I also heard Mr. Natarajan said, the customer really doesn't know whether he's getting green energy or he's getting power generated into the grid. At the end of the day, it's one electricity. So with the new technologies that come in, the user will have dashboard, the user will have the information right in his system to understand which source of power is generating how much units, at what time, and whether he is going to actually use it in his system. Specific to the energy storage, I think so this is a concept which is really good. Only the affordability part needs to be addressed. But then this is one technology which is going to ensure that your systems are optimally utilized. You don't have a burden. Why this is important? Imagine you need to, let's say, in a particular commercial complex, suddenly add maybe say 20 or 30 or 50 EV vehicles, and each try to consume, let's say, some fast DC charging. You will have to generate a new infrastructure right within the facility, but at the same time, right from the utility generation or maybe say substations to this facility, which is going to inconvenience the entire city system, because you'll have to dig new cables, you'll have to create new distribution connections. But creating this facility within your premise, storing it into your premise and using it when you have the peak demands is going to be an ideal solution. The government is playing a role to ensure that as a policy, the utilities are supposed to feed power by minimum 1% of their entire distribution through energy storage system. So that's one rule that is actively under consideration. By 2030, the utilities have to build that capacity of energy storage. So that's the grid scale, or the, let's say, the generation scale energy storage. As consumers, as users, we can do that our part by creating a small smart grid networks at our. That's my take on it.
We appreciate you sharing the details with us, sir. And moving forward, I would like to speak to Dr. Natarajan. What are the economic and environmental implications, of transitioning from traditional fossil fuel-based power generation to more energy efficient and sustainable alternatives? And how can these be quantified and compared? Mr. Natarajan.
Thank you. Indeed, a very, very important and valuable question that needs to be debated. We are already over 42% in terms of renewable energy as far as our installed capacity is concerned. And I think the latest numbers are somewhere around 20 or 23% as far as energy generation is concerned. We are rapidly ramping up the availability of EVs, whether it is two-wheelers or three-wheelers. The four-wheelers are still in small numbers, but their capacity in terms of charging will probably be equivalent to multiples of two-wheelers or three-wheelers. The 2-3 main issues are coming up in terms of the environmental impact. First is in terms of the critical materials that are required for all these alternate sources of energy to be manufactured and their environmental implications. There are a number of organizations that are working on this that say that we are not really estimating the environmental implications of mining these materials. If you talk of iron ore or coal or any of these minerals, we have been estimating the environmental impact, costing them and including them somewhere in the pricing process. As far as these critical minerals are concerned, I am not sure that there is enough information to say that we are incorporating the environmental costs of manufacturing, producing these critical items required for these alternate sources. The second issue that I believe we need to address is that in 5 years' time, you will need perhaps, I don't know how many estimated numbers of batteries that need to be replaced. These would need, again, more chemicals, more investments, and the fact is, what do we do with the disposal process? This is a completely gray area as far as we are concerned now, because disposal of these items has been the biggest challenge. Today, there are disposal rules for mercury, disposal rules for several other items. They are not followed, if I can say, at all. There are recycling people who are probably doing less than 10% of what is being generated as a waste. In this situation, are we really in a position to calculate the cost of recycling and bring it into the costing of these materials? I suspect that again has not been done. Let us also remember that unlike conventional energy where you are burning coal, a primary fuel, and you are generating electricity, in the renewable energy system or batteries, you are getting electricity from the sun, getting it through renewables, converting it into a chemical energy in the battery at significantly lower efficiencies than conventional power system generation. And then you are going to be using it in your end-use vehicles and systems. Is this something that has been taken into account at all? I believe that there is a lot of work that needs to be done to quantify the environmental impacts of manufacturing and disposal or recycling of these materials. There is not enough material in public domain, and we need more institutions to work on this and the government to seek more information while approving such projects. I'll stop here. Thanks.
As said, lot of things needs to be done actually. Mr. Kadam, how do you observe this transitional change? What's happening now for energy, and how do you compare the reaping benefits of them? How do we, reap the benefits?
Okay. See, whether we want it or we don't want it, the new world of energy is there. We call it a new energy landscape, right? And that's the only way through which we can decarbonize our world, or maybe try and reduce the greenhouse gases and make our life on the Earth is more and more sustainable. Otherwise, we will be highly unsustainable. Now, the transition to greener part of energy, solar, wind, or any other forms of greener energy is definitely sustainable, but has a lot of issues in terms of integrating that with our ecosystem, right? If there are technologies which can help, manage those lacunas or the shortcomings of these new energy entities, we will definitely sustain, and we are fast progressing. Let me give an example. The intermittency of solar and wind can be better integrated with forecasting, can be integrated with some kind of a demand response or curtailment service providing. So whenever the output from the renewable source goes down, you also reduce your consumption appropriately by incentivizing people. Similarly, we would want to decarbonize transportation, or at least the mobility inside the cities, or maybe even the long-haul vehicles. But those would add a lot of pressure on the existing grids, right? But if there are technologies to manage the scale and manage the complexity locally, I think we can still better accommodate. As Mr. Ripunjay was mentioning, for in-transit and for long-haul, you need to have megawatt scale charging. And that megawatt scale charging, instead of depending on the grid entirely, can it also depend on a local microgrid? Can there be a local storage? Can the corridor on the road on either side be fully solar, the way they are doing it in the Scandinavian countries? So can there be a low voltage management system which can take care of itself without passing on the disturbance to higher order system? For all the DR behind the meter, DR in front of the meter, or any kind of electrical vehicles connecting and all those new world energy, right? So you definitely will come up with newer and newer technologies to take care of this transition, and we will better harness it. I think it's a problem-solution statement. You have a problem, you have a solution. Solution creates another problem, you have another solution. But just that we need to intensify and increase the speed of solution. We cannot be going the way we are going for a long time. This conventional generation, transmission, distribution is there for age-old times. We have done enough damage to the mother earth, but I think not anymore. Probably we'll have to be fast converting on technology.
Right, sir. Well explained. Now I would like to move to Mr. Parekh. The question is, how do regulations impact advanced energy management in India's power sector, and what hurdles hinder their implementation? To you, Mr. Parekh.
Yeah. So let me start with a few basic pointers, what I appreciate also. Today, the government of India is possibly a role model today in the global scenario. The way we are adopting the carbon emission norms, the way we are adopting the new technologies of renewable power, talking of adoption of EV and other future technologies, especially in the fuel cell and so on. So the government will is there in terms of, let's say, the highway electrification program. While yes, a lot needs to be done there, and the way that its geography is large, but the government has a dedicated, I would say, wing called NHEV, National Highways for Electrical Vehicle, which is coming up with, let's say, engagement with various stakeholders to see how we can create an infrastructure, which is suitable for EV vehicles. What I see in the cities, the government is again, pushing at the policy level to ensure that the public infrastructure, especially the buses, the commercial buses, are faster, let's say, transition from the diesel fuels, let's say, CNG-based fuel to EV. And that's where we are seeing a lot of momentum happening. And that's where you build up, let's say, an EV charging space within the city, which is good enough to, let's say, talk of a 300 kilometer run with a single charge. So that's on the policy. In terms of, let's say, the user experience, I would say, yes, today there is not much differentiation. It's maybe an individual driven choice today, whether I want to go for an EV vehicle, whether I want to go for solar generation in my facility, or whether I want to, let's say, do a smart grid. The awareness is going to be a major issue. The government is also, let's say, talking of bringing these policies and maybe benefits that are available as a part of these policies, whether it's subsidies, by way of, let's say, publicizing it. One more element, slightly away from your question, I would talk is in terms of, let's say, the side effect of these technologies. Today, your home was relatively a very safe place. You had 230 volt AC power or a 415 volt AC power coming in. The incomer, you have, let's say, one residual circuit breaker which ensures you are protected or the humans are protected from electric shocks and so on. That's a good enough infrastructure. Going forward, when we talk of integrating the EVs, electric vehicles, solar power, which also generates power at DC that gets converted to AC and so on, we are bringing in a lot of DC networks and power within, let's say, very close to the human proximity. And maybe to an extent, either it's a, let's say, pulsating AC which gets converted. So our protection systems, especially for the humans, needs to get upgraded to factor in these safety elements. Today, let's say the classical home was okay with the type AC RCDs, which is good for human safety. But tomorrow, this may not be sufficient, especially where the DC comes in, you need to go for type B RCDs, and otherwise where you have the electronics, you need to go for type A. So the consultants, the designers, as well as, let's say, the CEA, the Central Electricity Authority, is already working on this to come up with, let's say, rules to ensure the new age infrastructure is still safe for human, and we don't create a problem of a different scale. That's my take on it.
I would like to ask Mr. Kadam, it's like you are a technology expert actually in this industry. So which challenges are creating roadblocks for the companies to adopt and implement these advanced systems?
So you're talking of the technology user, I presume, when you say companies, right?
Right, sir. Are there any challenges or roadblocks, things like that?
See, the biggest challenge is I don't know. I think most of the companies who are dealing with power sector are mostly government based. They are basis tender rules and regulations, So there is less and less chance for them to learn by experimentation, So there has to be a hard bound, technically firm, commercially firm RFPs for them to procure, right? I think that is something which is one of the main hindrances. Second is the technology user should work in partnership with technology supplier, not always as a supplier, not always as a vendor. So it should be a technology partner. So if they can look at the ways and means to make the technology companies to be their partner, that would be great. Because this is co-creation. There is nothing which is hard and fast made. If a product or a solution has to be made, there has to be a standard behind it. And things in this new world of energy are changing so fast that there could be sometimes a disruption by one company or many companies, or there could be a standard set by a consortia, industry consortia, or industry customer consortia, or industry technology user consortium. And then the standards may catch up later. You cannot procure it by tender. The next hindrance is the task force within the technology user company have to be soldier style group. To the purpose fit people have to be curated into special task force to do the work. Many often you see the technology user side, the people who are trying to work or to deal with the technology are not from that background. So either they should augment the manpower with the right competence. There are many consultants. Who are deep think tanks of that particular domain. So why doesn't the technology user get the services of those think tanks in abundance and make them as strong as possible? Instead of just trying to do everything standalone by tender, policy, grant, which is a big problem. You see, we started with drum project, distribution urban reforms project, then we came up to APDRP, then we came up to RAPDRP. We pumped thousands of crores of rupees. And then we are in the, through ESL, we are trying to invest into AMI 50 lakh meters. We should ask ourselves, what is the tangible gain out of all these digital investments made in the last 15, 20 years? Right? Are those systems working at all? Are they maintained? Are they able to extract maximum value out of them? The answer is, I don't think so. It's so much. It's like you implement because there is a legal. And then instead of using it, probably you go for another implementation saying that it's already old technology. It doesn't happen in the corporates. In the corporates, you buy a technology, you use it, maintain it, revise it over a period of time, and you extract maximum return on investment. I think biggest problem is intellectual knowledge within the utility, and then the flexibility of procuring in partnership mode. The L1 basis, the L1, L2, L3, the lowest basis is not the right way to procure technology going forward. So that's my two words on this particular hindrances.
It's like we'll be heading to wind up. The next and the last question to Mr. Natarajan. So it's like what innovative strategies in India address renewable energy intermittency, improving integration, storage, utilization, while maintaining a supply-demand balance to Mr. Natarajan.
Thank you. In one of the meetings I had recently, a couple of weeks back, one of the speakers made a very important point. We have till now been projecting and planning for renewable supply. We want to estimate how much supply will come next hour, next 2 hours, next day, next week. We have very complex modeling systems. But the gentleman also said, we just said whatever is available, people will consume. But he also said, now it is demand that has to drive supply and not vice versa. Because the consumer will want power at different times of the day for different end users. You are going to charge different prices for different times. And the customer will keep moving his demand according to the price. It may be as synchronizing with the renewable energy availability, or it may not. With battery storage coming in, the customer will prefer to take cheap energy, store it in the battery and use it in times of high pricing. What do you do with energy that is available during high prices? The supply, where will it go? I think the supply side demand, supply side modeling, we have been doing a lot of things, but we need to look at demand side modeling. Also, let us remember that the concept of flexible demand, that means sending a message to the customer saying next 2 hours I want you to switch off your air conditioner, you will get 100 rupee incentive. If you do that, then I will decide what to do. Now, if you are not going to be able to match the demand and supply, you are in trouble, because generally, I think we might end up in a situation where there is excess supply and you don't know what to do with the supply. This is the first point. The second point is, if the storage costs really go down as people are saying it is, then I believe that colonies or towers like Gurugram and Chennai or Bangalore will become independent microgrids. They will buy solar power directly during the day, charge their batteries, and then what happens to the grid? what happens to the 150 megawatts, gigawatts of base load power that I have? Where is all that going to go? And this is where I think the challenge comes in terms of matching the demand and supply. There is too many unknowns that we have, and particularly the dark horse, and this is the charging infrastructure. While we know that 50% or more vehicles will charge at home or in parking lots during the day, there is the remaining 50% on the road, on the highways that will charge at random. And this is where you are not going to be able to figure out when that is happening. And this is the point that I think we need to understand. Understand customer behavior. Give him or her the information and the price and see how he responds. The flexible demand is expected to have saved billions of dollars in the US through flexible demand incentives. I am told that there have been 2 or 3 pilots in Tata Power, BSES and so on, where about 100,000 people have participated. They've got incentives of 50 to 100 rupees. Now, in this kind of a situation, I think people will respond to prices. So far, we have never looked at let me put it this way. We had time of day tariffs across the country for many years for industrial customers. Have we ever really analyzed the impact of the higher tariff on demand? I don't think any utility has done that. And just to tell you an off-the-record comment made by one of the utility chief engineers, he said, no, we don't. To me, it is simply extra money. That's all. I am really not concerned whether people are shifting or not. I have an excuse to charge 2 rupees more. I will charge 2 rupees more. Now that can't be the attitude, right? You are charging for an objective of not increasing revenue, but for managing the demand. And this is where I think we are going to be in serious difficulties if we are not able to understand the customer and give him the information and the tariff so that he can decide. This is where I see the biggest challenge coming in. This demand flexibility is going to create havoc if it starts happening, because utilities will prefer to cut the customer through an incentive instead of buying high-priced power at peak times. And this is a strategy. Now, what will happen to the power at peak times if you don't have buyers then? So this is where I think we need to look at both supply and demand in an integrated manner and try to understand customer behavior. This has not been looked at very seriously. I'll stop here. Thanks.
A nice comment on it. So before we end with the discussion, I would head to Mr. Parekh to give his statements, closing statements.
Yeah, I think so. Thank you once again, for hosting this session and giving us the opportunity to share our insights. We as users, as organizations, needs to adopt to the reality that we need to cut down on our consumption of fossil fuels or generation of greenhouse gases. As a leading power management company, Eaton is committed to bring in the most, I would say, user-friendly solutions, be it the systems that support energy transition and renewable energy, be it EV charging infrastructure, where we are working with multiple OEMs and agencies to build most efficient networks. Be it, let's say, adopting the use of non-hazardous gases in the switchgears, especially in the medium voltage space. Eaton is going to be on the forefront. We are now trying to see to it that the government initiatives gets very well acknowledged. Lastly, to the users, I would say look at, let's say, the overall cost of ownership rather than looking at only the capex or, let's say, a few incentives or T costs. I'm sure that is going to be the future. With that, I believe India is going to be a leader again in this particular arena also. Thank you.
Thank you, sir. So moving to Mr. Kadam, Please, your last statement, sir.
Thank you. I completely agree what Dr. Bhaskar said. We need to devise models to follow the customers. Okay, and those models will definitely be successful if we take customer in our strategy. And also, I would want to emphasize the point that we need more policies to make sure that we devise customer-friendly policies or incentivizations. Okay, and another important aspect is the intellectual knowledge within the utility. Some way to build it up so that we are trying to run faster in a shorter time. We need much technical intellectual capabilities with utility to take it over. While there are many companies who would want to really come and contribute, but it has to be a smooth journey for the companies to work with the technology units. So I would stop with that. Thank you.
Mr. Natarajan, would you speak something as your last comment on this?
Yes, I would want to say 2 points. One is that all the solutions we are talking about are going to be impacting, let us say, about 30% of the customers in the country who are upper middle class and upper class. Whether it is a clean green tariff for clean power, whether it is battery storage, whether it is EVs. I am concerned about what we are doing for the 70% of the population. Let me give you an example. I'm sure Mr. Kadam will be very well aware of this. The buildings that the government is building for the Awas Yojana, they are going to build some 1 crore, 2 crore houses for the poorer sections of the society. We have done a little bit of analysis that says that these buildings will be hot boxes. They are not designed for thermal comfort inside the buildings. And for the next 50 years, these people will run ceiling fans for 24 hours. And when their income goes up, they will buy air conditioners. And this is the problem that I am seeing. We are not paying attention to 70% of the population who are going to be impacted. And this is where I have a real serious issue. Because everybody says these people, they get anyway 50 units free, 100 units free, jane do unko. But that's not the way we need to see. You can't be a developed country with a $5 trillion economy if you're going to give away 30% of your electricity free of cost. And this is the challenge that I believe we all have to address. Thank you.
Very well said, sir. This is the problem of the...
Yes, you're right, sir. Thank you.
I acknowledge, sir.
Panelists, for exchanging your valuable thoughts on today's topic, advancing energy efficiency in the power sector. We hope you have enjoyed it. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Ripunjay Parekh, Mr. Anil Kadam, and Dr. Bhaskar Natarajan. For viewers who have joined us today, we would like to have your feedback and encourage you to stay connected with us via our social media handles. EPR Magazine is available on Facebook, Twitter, and Instagram. You can also download our app from Google App and Play Store. We would also request our viewers to stay tuned for future interactions. With that, today's interaction has now come to a close. Thank you and goodbye.